Flamingo Productions presents Fracking Revealed. You'll find out what fracking really is. The secrets behind the fracking fluid. The effects on the environment. The effects on us. Featuring an interview with Dave Chapman. And how we can solve this crisis.
Well, fracking is a process by which certain kinds of water and solvents are pushed down into layers of the ground that have some kind of petroleum in them. Usually it's a petroleum product that is stored in the rock itself. And by pushing this liquid down into the cracks and crevices of that rock, they shatter the rock, they break it apart to release the petroleum so that they can then take it back out again.
Jennifer Farragon, an agent of the Department of Environmental Quality, suggests that the fracking fluid won't leak into the groundwater because Michigan has strict regulations on how much water can be used, how the wells are constructed, how the wells are tested before they are used, and how the flowback water, which is pumped back with the petroleum, is contained and disposed of. In theory, these 4 regulations are supposed to be followed, but whether they are or not depends on a lot of things, among which the location of the well and who's working on site. Hydraulic fracturing is the process of shooting fluids into the ground at immense speeds, forcing layers of shale roughly 5,000 to 10,000 feet beneath an aquifer to crack. This releases the oil held within the shale so that it may be pumped back out for use. Universal Wells Incorporated says that it is a safe process because they encase the wells within a layer of cement. But this does not guarantee that fracking fluid won't seep into our water supplies.
My understanding is that there are a couple of concerns. One is that the material that they're pushing into the ground sometimes has solvents in it that if they were to get out into the groundwater or into the surface water may cause a problem for people or other living things.
In fact, over 1,000 incidents have been reported where fracking fluid has leaked either into an aquifer or into surface water. This fracking fluid is mostly made up of sand and water, but every second about 60,000 liters of chemicals that are dangerous to our health are pumped into the ground. Among these chemicals are propant, potassium chloride, and biocide, as well as a number of friction reducers, gelling agents, scale inhibitors, pH adjusting agents, breakers, cross-linkers, iron controls, corrosion inhibitors, and acids. The results would be devastating if any of these leaked into the groundwater. For example, hydrochloric acid can cause burns in the mouth, stomach, or throat if swallowed, and it can also cause ulcers on the skin and partial and sometimes complete loss of vision. There have been lots of cases where people's water have been so contaminated that they could literally light their tap on fire.
If a lot of material is extracted and is extracted in a way that some of it leaks, either on the way back up to the surface or at the surface, then it could contaminate water and the contaminations could be unhealthy.
This site just south of Mason is one of many that are located all over Michigan that use fracking in order to extract oil from shale. Hydraulic fracturing has been known to have harmful effects on humans and the environment. Fracking involves the shooting of chemical fluid into the ground. This fluid, if any gets into the water supply, is dangerous to our health. Harmful effects include burning of the skin, vomiting, respiratory infection, headaches, neurological impairment, nausea, and skin rashes. After the fluid has been used, fracking companies dispose of the used fluid, or flowback water, by hauling it to water treatment facilities. However, they are often under-equipped to handle the chemicals in the fluid.
Well, I think a common thought is that we should be using a variety of sources of energy and a mixture of sources that maintains an adequate supply for the style of life that people seem to insist upon, but at the same time minimizing the environmental impacts. And so I think there isn't a single source of energy that is the one source that we should be relying on. We should have a variety of things. And solar and wind are some of the alternatives that have been talked about a lot, and yet there's a lot of criticism, people suggesting that they aren't practical. In fact, they're a lot more practical than I think people realize. There's a solar collector on a school in Michigan, which in fact I have seen generating electricity on a moonlit night. So when we talk about a lot of sort of cloudy days in Michigan, maybe that would make solar energy not a practical solution. Well, it may not generate as much electricity on a cloudy day, but even on cloudy days, it will generate electricity. So I think we need to relook at the questions about the various alternatives. Geothermal, which is a term often used to apply to collecting heat near hot springs or volcanic activity, or places like Yellowstone or Iceland where there's a lot of volcanic heated water near the surface. Geothermal can also be extracting heat out of groundwater that is around here, around in our backyard. If you go down 5 or 6 feet in the middle of winter, the temperature there is, quite a few degrees warmer than it is at the surface. And if you pipe water out through the ground and back into your house, you can use a simple heat exchanger like the one that's used with air conditioning systems or refrigerators to extract that heat and pump it in the house. And there are houses in Michigan who use geothermal very routinely. I think there are a lot of things that we haven't explored and a lot of people don't understand very well, alternatives that should be looked at, and we should include them as a part of it.
One of the solutions to hydraulic fracturing is renewable energy. Solar, wind, hydropower, and geothermal are some of the many ways that we can harvest green energy. The reason renewable energy is not that popular is because people don't want to make any drastic changes or don't really realize the benefits of renewable energy. For example, one wind farm can generate about 1.6 megawatts of electricity, which can power about 432 homes. An average wind farm consists of about 125 windmills, which would generate electricity for over 54,000 homes. This project, while it would cost $440 million, produces an unlimited amount of energy, whereas fracking companies would have to continually relocate once they've exhausted the petroleum from a certain site. Solar energy, while also costly to install, would generate electricity for 12,000 homes a year. While it would cost several $1 million to install, it would save a lot of money in the long run. No matter what people believe, the only true long-term solution to this energy crisis is nuclear fusion. Currently, nuclear power plants use nuclear fission, which is the splitting of atoms. This process generates a lot of power, however, the waste produced is highly radioactive and takes a very long time to completely decay. Nuclear fusion, however, is the combining of atoms. Now, this process generates far more energy than fission, and the waste that is created has levels of radiation that are too low to affect us in any way, if any levels at all. The only major drawback to fusion is the immense amount of energy that is required to cause it to occur. With the technology that is currently available, we have to spend more energy to create fusion than what is produced. But there are many research facilities that are hard at work trying to figure out how to overcome this barrier. If we can harness nuclear fusion, then we can harness true clean energy.